everyone, my name is Miss Lauren Proda. Welcome. You are now a pro student in my math class. Today, I am going to teach you an amazing connection between math and art and show you how you can make your very own project with tessellations.
Miss Proda, what's a tessellation?
A tessellation is a pattern of shapes that fit together with no gaps. Here's a tessellation of squares. A square is a shape with 4 equal sides, 4 right angles, and opposite parallel sides. A square can tessellate because each vertex or corner point is a meeting point of 4 squares with no gaps.
Miss Proda, are there other shapes that tessellate?
Yes, there are 3 total shapes that can make what we call regular tessellations. Squares are one of them. Let's see what the other 2 are. A triangle is a shape with 3 sides and 3 angles. There are different types of triangles, but only equilateral triangles that have equal side lengths and angles can tessellate. Equilateral triangles can tessellate because each vertex is a meeting point of 6 triangles with no gaps. Here's a tessellation of hexagons. A hexagon is a shape with 6 sides and 6 angles. A regular hexagon, with all sides and angles equal, can tessellate because each vertex is a meeting point of 3 hexagons with no gaps. Those are the only 3 regular tessellations.
Miss Proda, those are cool, but are there other types of tessellations?
Yes, there are. Semiregular tessellations are made up of 2 or more shapes, specifically polygons. Let's see what we can find. Here's a semiregular tessellation made of hexagons and triangles. It's a semiregular tessellation because the pattern at each vertex is the same. Look at any vertex and you will see the meeting of 2 hexagons and 2 triangles. Here's a semiregular tessellation made of triangles, squares, and hexagons. Take a look at each vertex to see that they're all the same. You should see the meeting of 2 squares, 1 triangle, and 1 hexagon. This is not a tessellation. Does anyone know why?
Well, there are gaps between the shapes. In tessellations, there are no gaps.
You are correct. Demiregular tessellations are different and somewhat problematic because mathematicians don't agree on exactly what they are. But they can be used to create some really unique and abstract art. Hey, pro students?
Yes.
You are actually the perfect example of a demiregular tessellation.
Wow.
Hooray!
Yay.
Let me show you how to make one at home. First, we need a small rectangle. Fold your paper twice in both directions to make a bunch of small rectangles for us to use. Then, cut one of them out. Draw a line as crazy or as simple as you want from top to bottom. Then, cut it out. Move the piece that you cut to the other side and tape it on. This is already a tessellating shape, but if you want to make it even crazier, draw another line, this time from side to side. Carefully cut it out. Move the new piece to the other side and tape. Wow, look at this tessellating shape. Here are some of the other tessellating shapes that I created. Does one of them look familiar? Trace your shape several times on paper and watch how perfectly it connects every time. As you can see, regardless of whether I trace to the left, to the right, to the top, or to the bottom of my original shape, it's going to work perfectly. You can use your imagination to design your tessellation, or leave it how it is and allow your viewers to use their imaginations. Here is my final design. I designed my tessellation with surfers riding waves, and under the water, a creepy sea creature. All from this shape. Art and math go perfectly together. Look all around you in your everyday life to find real-world tessellations. They're there. Floor and wall tiles, brick walls, carpets, honeycomb, and more. See what you can find. Pro students, class is dismissed. Great work today.